Good afternoon, everyone. My name is Abdullah Abuhabaya from King Abdulaziz University, Mechanical Department. I'm going to talk about biodiesel production and use it as fuel in internal combustion engine. We have a lot of oil and natural gas in Saudi Arabia, but also we're looking for renewable energy, especially biodiesel. My study is combustion heat release models of biodiesel. The format of presentation, I will be talk about aims and objective of this study, experimental setup, fuel manufacture process, result and discussion, and finally will be draw conclusions and recommendation for future work. The first aim is to investigate the viability of using biodiesel as fuel in combustion ignition engine. The second aim to be evaluate the engine performance, such as torque, power output, and brake-specific fuel consumption, something like that, to running with biodiesel and traditional fuel. To obtain this aims, we have two objectives: to find an immediate alternative energy solution without any modification in engine structure. Also obtaining one of solution which is reduce the global gas emission with same engine performance and reduce exhaust gas emission. We have two types of biofuel. One of them, first generation, as we're talking about biodiesel and bioethanol. Biodiesel by transitification of fresh or used vegetable oil, and bioethanol by fermentation, starch, or sugars. Second generation, not available yet. The experimental setup, biodiesel production and fuel properties, and finally, engine testing. By this machine, fuel bud machine, is basic unit for manufacture of biodiesel by transitification process. We have lower tank, contain any type of vegetable oil, the capacity about 50 liters, and small containers has a mixture of methanol and catalyst, sodium hydroxide or potassium hydroxide. After about 20 hours, we have biodiesel and glycerol. The chemical reaction for conversion of vegetable oil to biodiesel, we have vegetable oil and methanol and catalyst, sodium hydroxide or potassium hydroxide or sodium hydroxide. After 24 hours, as I mentioned, we have glycerin as dark brown, and we have fatty acid methyl ester or biodiesel. Also, we should make sure the properties, for example, for kinematic viscosity, we used U-tube viscometer to measure kinematic viscosity and hydrometer to measure density and pump calorimeter to measure calorific value. Here the engine test facility, steady state engine test rig, with dynamometer. And also we have the CB engineering data acquisition to collect engine performance, fuel consumption, power output, engine load, engine speed. And we have HORIBA exhaust gas analyzer to measure exhaust gas emission. After that, we have a result, about 49 liters of biodiesel from 50 liters of vegetable oil and 8 liters of glycerol. This table shows the fuel properties: kinematic viscosity, calorific value, cloud, pure flash point, and density. We have significant change in kinematic viscosity before transitification, about 40 millimeters square per second, and after transitification process, we have about 5 millimeter square per second, which is good. No significant change in calorific value. This data is acceptable according to American Society for Testing and Materials standards for maximum allowed quantity in diesel and biodiesel. These figures show the variation of engine performance with engine speed, with different engine speed at full load for standard diesel and 6 types of biodiesel. There are increase in power and torque with biodiesel, but it's very small in most cases. This reduce in power and torque due to the lower calorific value for biodiesel, the lower calorific value for biodiesel. And we have increase in brake-specific fuel consumption. This may be attributed to high density and high fuel consumption and lower power due to lower calorific value for biodiesel. And we have good result for thermal efficiency with biodiesel because biodiesel has oxygen and high cetane number. Here we have variation of brake power and brake torque with different percentage of biodiesel blend. 5%, 10%, 5%, that means 5% of biodiesel mixed with 90% of fossil fuel or diesel fuel. Also, we have reduction in power and torque as proportion of biodiesel increase in the blend. Here, the variation of different gas emission with biodiesel blend percentage for carbon dioxide and carbon monoxide, hydrocarbon, and oxide of nitrogen. The biodiesel should be decreased. The carbon monoxide and hydrocarbon emission with a slight increase with oxide of nitrogen and overall similar values of carbon dioxide. Here we have variation of in-cylinder pressure for different fuels: diesel, B10, B20, B30, B40, B100, at different engine speed and loads: 1200 RPM, 14, 16 RPM, 1600 RPM, and different loads. Also, the in-cylinder pressure increase with increased engine load and engine speed, which indicates that the biodiesel is alternative fuel. Here, comparison of the rate of cylinder pressure rise, the same behavior with heat release rate. Okay, the conclusion is the fuel bud machine process was used to production of biodiesel by transitification process. After esterification vegetable, the kinematic viscosity reduced from 40 to 5 millimeters square per second. That means we can use biodiesel in compression ignition engine. By running biodiesel, there are decrease in almost of emission except oxide of nitrogen. The study has shown that no matter what type of vegetable oil, we can use fresh or used vegetable oil. The combustion profile of biodiesel fuel is very similar to that the baseline diesel fuel, and similar torque is demand for the engine. Okay, recommendation for future work. Future work should be conducted in actual road to see the impact of driving a car varying weather conditions, how the driver affect the emission efficiency and engine performance. Also, we can investigation and characterization of combustion of mixture of biodiesel with methanol or ethanol or other biofuel. Study to optimize the properties of biodiesel production from canola oil or geothermal oil. Thank you very much. And any questions?
Thank you very much for your presentation, and
Welcome.
thank you for keeping for time as well. And we have time for some questions now. Any questions?
What is the cost of your biodiesel in comparison with diesel fuel conventional?
In my company, this is expensive because the petrol fuel like cheap, like free. But in other country, it's not bad. You mean the cost of oil and methanol and this equipment, yeah? This is your question.
It's clear.
Thank you for such an informative talk. I may be wrong, but there I saw an advertisement. They would charge me $1,200 to convert my diesel engine to an engine that can use directly the oil, just the waste oil that you can get, for example, from Dunkin' Donuts or any other places.
Yeah.
Now,
We can use used oil
directly,
for free.
Right. Directly that go to the engine and that work.
Okay.
Now, what's the point to convert that to metal ester and then put it in the engine?
What? Sorry, say again, please.
What is the point of that chemical reaction to convert
converting
vegetable
the
oil to other products,
Yeah.
while you can put it directly in the engine.
Yeah, this is just a solution for our alternative fuel. But until now, the biodiesel is expensive than petroleum diesel.
Any one more question?
Thank you for your presentation. I have two small questions. For biodiesel, do you have to adapt the engine to run it?
Yeah.
What do you have to adapt to the engine?
What, sorry?
You said biodiesel, various blends of biodiesel can run the engine, or the engine can run on it. Do you have to adapt the engine? Do you have to increase pressure and intake pressure, or something else?
Yeah, almost similar.
Almost similar.
Yeah, almost similar.
Because
No.
if you want what he discussed, if you want to use oil directly into a compression engine, you have to convert it quite heavily. That's why he charged $1,200 for it. But with biodiesel, you cannot use it more direct, or not?
Cannot use it as pure biodiesel. We can use it
And blends.
in blend. Yeah.
Okay. And did you also check how much percentage is maximum allowed to get similar results?
I use until 100%, but 20% is the maximum.
20%?
Yeah.
Okay. And it's also...
And in UK, United Kingdom, there is a petrol station use B20.
Yeah, a B20, okay.
Yeah.
But there are no difference in density, that you get a two-phase fuel. Because if you store biodiesel too long, you get maybe that the bio part will move up or move down, and you have not a blend anymore.
Yeah.
And that's also the case in your case?
Yeah.
So you have to...
If you store it,
Yeah?
what will be happen?
Yeah, then you get different layers of density, or not? You get two or more phases, or just is it a homogeneous?
I'm not sure about that.
You're not sure about?
I'm not sure.
Okay.
Because I'm mechanical engineering. Right?
Yeah, me either.
This chemical question.
Okay, I think we can do that at the cocktail hour. Actually, it's time to move on with one more question with. Yes. Oh, maybe
Yes, okay. How do you control the reactions of the esterifications biodiesel? Because maybe this question, we have the response of all of the questions, including the machine, the use of the motor, because you can, because you have to control the subproducts like diacetyl glycerols and monoacyl glycerol. That's not good for the machine. If you have the complete reaction, you have no problems. Do you control? How do you control when you did the biodiesel?
This machine, fuel bud machine, is automatic control, but we control temperature and catalyst, amount of catalyst and amount of methanol.
But the subproducts.
Sorry?
But the subproducts. The end of the reaction to products. Because you get biodiesel, it's a reaction. Biodiesel is a reaction.
Yeah.
Esterification reaction. And biodiesel is good if you have complete or all complete reaction. Because the subproducts like diacylglycerols and monoacylglycerol is not good for the machine. This is maybe the answer for your question.
Yeah, not do that.
Yeah? But I understand that you will begin to use. Yeah?
The injectors will break down.
Yeah, because
At the filter. You have to change and create new filter. Yeah.
Some parts will, how you say it, break down the injectors of the diesel engine, and that's why it's not, you can only use it 20%, because if you use it too much or too long,
You have to change the filters,
Yeah.
new filters.
the fuel filters, the
Few
injectors,
filters, yes,
and
yes.
that's quite costly.
But I understand that you
Yeah, yeah,
say
yeah.
to use it in your machine and something like this.
Yeah, yeah.
That's okay. Thank you.
Again, also to your question, the engine is lambda controlled. So he said there's a computer, the ECU, and that controls the temperature in the outtake of the outlet manifold, and that's why.
But it's not sufficient. You have to do the
Yeah.
reaction. Yeah.
Okay. Thank you very much for that. Thank you.
Short question related to the quality of your starting material.
Yeah.
Did you take refined, normally in vegetable oils or whatever, you have, or let's say grease, brown grease from pork, you have free fatty acids in. And did you remove the free fatty acids? Did you refine, or did you carry out a pre-esterification of it? And can you say a little bit more about that? Otherwise, your sodium hydroxide will be ruined after a few minutes.
Yeah. We remove free fatty acid
In which way?
by this machine.
By that machine?
Yeah, by fuel bud machine.
Okay, thank you.
Thank you very much. I know it's important to keep the
And
time.
after we collect the product, we test the free fatty acid. If the percentage of free fatty acid acceptable, we can use it. Is that your question?